Analyzing categorical data. Students will be able to interpret bar graphs, pie graphs, and two-way tables for categorical data. And students will be able to create a bar graph and two-way table for categorical data. In this lesson, we'll be looking mostly at examples from your book. We're on page 8. So it says, we're looking at radio station formats. The Radio Audience Rating Service, Arbitron, places U.S. radio stations into categories that describe the kinds of programs they broadcast. Here are two different tables showing the distribution of station formats in a recent year. So if we look at this table here, it tells us exactly how many stations play adult contemporary, adult standards, contemporary hit, country, and so on. As you can see, there's a total of 13,838 stations. Now, I want you to think about this. Why is this categorical data and not quantitative data? Take a minute, pause the video to think about your answer. Okay, well, these are categories, right? We're not measuring anything, we're just counting how many stations fall within each of these categories. This is a frequency table because it's giving us counts. Now we can look at this relative frequency table. This relative frequency table is actually going to help us construct a graph to represent the data. Relative frequency gives us the percent. In the last lesson I showed you how to find a percent. You take the number in each category, so in this category 1,556, and divide it by the total. Now it says 11.2, but if you did this division, you would have gotten 0.112. Multiplied by 100, you get 11.2%. As you can see, my total almost adds up to 100. The only reason it doesn't quite get there is because we rounded these values to the nearest tenth. In reality, whenever we do a relative frequency table, all my percentages will technically add up to 100%. So let's summarize a little bit. Our keywords are frequency, counts of individuals within each category, so we're saying 1, 2, 3, 4, 5, and relative frequency, percent or proportion of individuals within each category. So that means we're taking the number in each category divided by the total, and the percent for all categories added together should always equal 100%. Now there are a couple ways we can display this categorical data. So we can use a pie graph, which is based on the percentages. Each of these slices of this pie represents a certain percentage of the area of this circle. So they give us this example here, that because 14.9% of stations were country stations, this pie slice represents 14.9% of the pie. We can also use a bar graph to represent this data. So for example here, we also use percentages to label the y-axis, and then on the x-axis we name each of our categories. Notice that there's a gap between each bar. The gaps are of equal width, and then the bar rises to the percent that makes up each category. And so you can see visually here that news and talk stations have the highest percentage of stations within that category, followed by country and then religious. So both of these data allow you to see, or both of these displays allow you to see visually which categories are most represented within this population. Okay, so let's look at a problem where we're going to construct a bar graph to represent the data. It says the most popular colors for cars and light trucks change over time. Silver passed green in 2000 to become the most popular color worldwide, then gave way to shades of white in 2007. Here's the distribution of colors for vehicles sold in North America in 2011. Now, looking at this table, because it's percent, we know this is a relative frequency graph. And we have 9 categories that are represented by color for these cars. The first question says, what percent of vehicles had colors other than those listed? Well, let's go ahead and add up all the colors or all the percents for each of these colors. When we add them all up, we get 99%, which tell us that other colors bought for cars were in the 1%, because we know that our total percent has to add up to 100. Now it says display these data in a bar graph. Be sure to label your axes. So let's see if we can do this somewhat quickly. So I'm going to draw a graph like this. Might need to make it longer. And on one axis, I'm going to list the car colors. So on the x-axis, I've listed all my colors that were in the two-way table. Now on this y-axis, I'm going to go ahead and list the percentages. As we can see, the highest percentage goes up to 23. So I'm going to count by twos and go up to 24%. They did say to be sure to label my axes. So on my x-axis, we can say color of vehicles sold in 2011. And then on my y-axis, I can say percent of vehicles. Now the next thing I want to do is construct the bars that rise to each of the levels indicated by the table. Okay, and so you can see that I've shaded in the bars for each of my categories. If you notice, I've tried to keep the bars about the same width. That's just so that one doesn't look like it's visually taking up more horizontal space than the other. And then you can see how tall each of them rises. White was obviously most popular, with green being the least popular. Now you try. Go ahead and work on problem 10, where you will also be constructing a bar graph to represent the data. You'll also be trying to figure out exactly what percent of spam falls into the other category. The problem reads, email spam is the curse of the internet. Here is a compilation of the most common types of spam. Go ahead, pause the video, and work on this problem.